Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at lvalues and rvalues. This is going to seem a bit academic, but it turns out to be very important for what we're going to go on to do when we look at move constructors. So since C++ was created, we've had this distinction between lvalues and rvalues, which hasn't previously been all that important. So if we type something like int value 1 equals 7, we've always said that value 1 is an L value and 7 is an R value. So the L and the R come from left and right because they're on the left and right of this statement. Now C++ 11 extends the definition, or it changes the definition of L values and R values, and they become a lot more important for reasons that we will soon go into. In C++ 11, a L value is basically anything you can take the address of. So clearly here, if we say int pointer p value 1 equals address value 1, we can do that, and that shows us that value 1 here is an L value, but we can't type int pointer p value 2 equals address of 7, because 7 is an R value and we can't take the address of R values. So if we build this project, then it's not going to work. The same thing applies with objects. So that was just a primitive value, but if I type, well, actually we've already got here's actually a good example of an expression where we can see this at work. So test1 here is an L value. It's a named value which we can take the address of. We can say test pointer p test1 equals address of test1. That's going to work. On the right hand side of the equation here, we actually have a R value, because the return values of functions are R values, and R values are often temporary values. For example, the values returned from functions. So what we can't do is we can't say test pointer p test2 equals address of get test, which is our function that returns a test object. And the reason for that is that the return value is an R value, which is a temporary value in this case, so we're not allowed to do that. Sometimes the distinction between L values and R values is a little bit hard to define. So for example, now we've got this value 1 here, and did I say define? Not define, but it can be confusing. So it can be not, it's never hard to define as such. There's a strict definition here, but it can be rather confusing to figure out which is which sometimes. So if we say int pointer p value 3 equals value 1, and we're going to take the address of that, we've seen that works. What also works is if we put ++ here, and what that gives us is, of course, the prefix increment operator increments the value and then uses it. So in this case, p value 3 is going to end up referring to 8. So let's just prove that. And so we'll dereference p value 3, and we'll run this program. So this works, and we get 8. There we go. But on the other hand, a little bit surprisingly, if we try this, you may guess what I'm about to do. If we try this and we use a postfix increment operator, and then we try to output value 4, well, we don't even need to output it because it's just not going to work. So if I try to build this now, we'll get an error. The reason for that is there's a temporary value in here, because the postfix operator needs to use the value and then afterwards increment it. So it has to create a temporary copy of the value so that the actual original value can be used, and then we can increment basically a different value. There's got to be 2 values in there somewhere. There's got to be one that you actually use and one that you increment. And so this temporary value is introduced to make that work. And here C++ thinks we're trying to take the address of a temporary value. So this is an L value, it's fine, but this is an R value. We can't take the address of a R value. There are lots of other examples I could give. We'll probably stop there, I think. So when you have expressions like int s equals 7 plus value 1 or something like that, okay, value 1 is itself an L value, but this whole thing here is an R value. You can't put brackets around that and take the address of it. Let's prove it. So int pointer s equals address of that whole expression. That's not going to work. So that expression there, 7 plus value 1, this is an R value, even though value 1 is an L value. So that's basically it from this tutorial. It takes a little bit of time to get your head around this. So I would very much recommend that you just try this a little bit and try to find some examples of L values and R values. And remember that one of the most important places that we see R values is in the return values of functions. So just try this and verify that you indeed can't take the address of R values, and of course that you always can take the address of L values. So if you're completely puzzled, it's definitely worth typing this code out and verifying it for yourself with your own compiler. And if you can think of any other examples to test, well worth testing those as well, because you need to have this pretty well fixed in your head before we go on to look at L value and R value references and then move constructors. This is a slightly annoying thing about this, is that although move constructors are really great, as you'll see, they do require us to think a little bit more deeply than we might be accustomed to thinking, at least when you come fresh to this, moving from C++ 98. Okay, so until next time, happy coding.